Okay, today we're going to jump in and we're going to solve some log equations. So the first thing I'd like you to notice is take a look at the three equations I've put up on the screen, and you can see why those are referred to as log equations. Where is my variable? It's inside the logarithm. And so one of the strategies that we can use to go through and solve each of those is to get rid of the log. Really what we're doing is we're going to change the form. So if we take a look at the equation given in A, log 25 from base x equals 2, I can change my equation from log form into exponential form. And therefore, I would get x squared is going to equal 25. And now I've created a polynomial equation I can solve. We can go through and take the square root of 25, and I notice that I get plus or minus 5. Now, one key thing for us to touch upon. Is x able to equal positive 5? Yes. Is x able to equal negative 5? No. Because I know that everything inside my log, result and base, must be positive, therefore I would have to mark that negative value as inadmissible. So for you to provide a solution to A, I'd need to see all the red and the blue. Very quickly, we'd be able to work through the next one then. I have a log equal to a number, and so therefore I can change that to exponential. 3 to the exponent 2 gives me x, and I'm done. You take a look at C. As I work my way through C, I have a single log equal to a number, and therefore I can change that to exponential. So 3 to the exponent 1 must equal x squared minus 1. And now I have a polynomial, I can solve that. And I get x equals plus or minus 2. And then we've got our negative 2, so we mark that as in. Stop yourself. One of the common mistakes is that we put in our head that I can't accept negative x values. Do a quick substitution. If you subbed in x equals 2, notice your log becomes 2 squared, which is 4. 4 minus 1 is 3. X equals 2 is a valid solution. But also, if I sub in x equals negative 2, then I'm also going to get negative 2 squared is 4. Then when we take a look back at A, we did not mark x equals negative 5 as an inadmissible value just because it was negative. It's because it produced a negative inside the log. So you take a look at those solutions to those warm-ups, and that gives us our first key strategy to be able to solve a log equation. There we have it. That anytime you see a single log equal to a value, then we want to change that thing into exponential form, and then we solve whatever we have in front of us. That should be your number one strategy when solving logarithmic equations. Okay, let's take a look at another scenario. We may have something called equivalent logs, and I've just given you your piece of theory in red, and I'm hoping that when we take a look at that, it just kind of makes sense to us. That if I have a log m from base A equal to a log n from base A, well then, what's inside this log must equal what's inside this log, since the bases are the same. So, as a little bit of a duh moment, if I had log x from base 5, and that was equal to log 12 from base 5, well then, my x must equal 12. If I have a single log equal to a single log, and those bases are the same, therefore the results must be equal. We can use equivalent logs to go through and solve log equations as well. So let's take a look at question 2, and we're going to go through and we're going to solve a bunch of equations using both of those methods. So take a look at the very beginning, question 2a. You've been asked to solve that equation. You notice, where is your variable? It's inside the log. You got to get it out somehow. And one of those ways for us to be able to solve it is using equivalent logs. Notice that I have a single log equal to a single log, and those bases are the same. And so equivalent logs allows me to say then that 2x minus 4 must equal 36. This result must equal this result. Now, we don't care what you show us in terms of a solution after that. If we're good to add on 4 and then divide by 2, you can go straight down to an x value of 20. I want you to take a peek, though. We just solved for an x value of 20. Can I accept an x value of 20? Yep. Because if I did sub it back inside that log, I still have a positive value, and I know that I always need positive values inside every log. Take a look at B. Okay, I want everybody to pause it and give B a shot. Okay, we're back. And so, when you take a look in this scenario, you have a single log on the left side with the variable inside it. Our motivation should then be, well, if I could write the right side of my equation with a single log inside it, then I could use equivalent logs. And because I see addition in between my two logs, then I know that I can write that as multiplication on the inside. And now I have a log x equal to a log 21. Therefore, x must equal 21. There are two log equations where a pretty efficient strategy would be to use equivalent logs. Okay, we're going to start to get into something a little uglier. And I think C is going to represent more the type of log equation that you guys would need to solve. You take a look, and now you have multiple logs with variables on the inside. And so maybe one of our strategies might be to use something similar to what we just did in B. I would have predicted that I would have had a lot of people work their way through and say, well, I can get rid of this minus log if I add it to the other side. And they may create an equation that looks something like this. And now that they have addition in between my two logs, we know that we could write that as multiplication inside my log. Now, for some of us, that might look a little confusing, but if we put big brackets around that, we can tell that the x minus 2 times x plus 4 is all inside my log. Now I come back to my initial strategy. On the left side of my equation, I have a single log equal to a number. And therefore, my strategy should be to change that to exponential. So 7 to the exponent 1 is going to give me x minus 2 times x plus 4. And pretty quickly then, we should notice that we have a quadratic equation. And if we expand our brackets, recognize that we can't put our variables into one variable term, so we put it into standard form. And we love the fact that this factors, but I think everybody knows what they would have to use if it didn't factor. We get down to this. So, pretty direct through, not too bad. However, always, always, always catch yourself at the end and say, is it okay for x to equal negative 5? And if I take a look just inside the first log, I notice that if I was to replace my x with negative 5, I would have a negative inside my log. And so right off the bat, I know that negative 5 value is inadmissible. Is it okay for x to equal 3? Well, if I make the substitution inside my first log, yep. Second log, yep. Then I can accept 3 as my answer. Now, what lines would I need to see for you to be able to go through and produce that as a solution? The lines I need to see are the yellow starred lines. I think we should be okay to move a log to the other side or eliminate it from one side and then come right in on this line. Then we need to show changing that to exponential, but we can calculate 7 to the exponent 1. Now, unfortunately, I need to see everything else. Quadratic equation in standard form, factored, solutions. If you were to show me those 5 lines with stars, you have a great solution. I just want to maybe show you an alternate solution to that equation, something that you may have tried. Perhaps we might have looked at that equation and said, well, on this right side, I would like to just be able to create that as one term. And so maybe instead what we did was we said, well, I can put together that log x plus 4 from base 7 with the 1 if they were both logs. And so I could rewrite 1 as log 7 from base 7. And now on the right side, I have one log subtract another log. That means that if I'm subtracting logs of the same base, I must have had division inside my log. Now I have a single log equal to a single log. Bases are the same. Therefore, that result must equal that result. And now you've created an equation of which we can get rid of our divide by 4, or x plus 4, by multiplying it out. And therefore, I come in on my x minus 2 times x plus 4 equals 7. And that looks an awful lot like that. And you would be good to finish. So, 2 different ways to be able to solve C. Both of them probably equally efficient. Either one is a good strategy. Okay, I want everybody to pause the video now and give D a shot and see if they can work their way through D. Okay, we're back. So I would hope that for most of us, we recognize that the variable's inside of our log, we got to get it out. And since you have addition in between your 2 logs, that we may want to go through and multiply your 2 results. Now using the strategy of a single log equal to a number means you can rewrite that in exponential form. You now have a quadratic equation. And yes, it factors. Otherwise, we would be using quadratic formula. And therefore, we get an x value of 9 or negative 4. Again, remember, take a quick peek. Can I accept x equals 9 as a solution? Yes, all my logs will be positive. Can I accept negative 4 in there? And right off the bat, I noticed that if I was to replace that x with negative 4, I would have a log with a negative result. Therefore, that negative 4 needs to be marked as inadmissible. And that red solution would be a full solution to that problem. Hopefully we matched up. Okay, last equation. Everybody should be much more comfortable to go through and solve. Everyone pause it now and see what we can come up with. Okay, we're back. There are so many different ways to go through and solve this. If I had to predict what I thought would be the most common approach, I would expect an awful lot of people to take that negative log at the end and possibly move it to the right side or get rid of it on the left, and then work their way through some process of equivalent logs. I would expect that to be the most common. I'm going to put up an alternate solution, though, because I do think that this is an opportunity for us to examine a common mistake. So, maybe I look at the fact that I have 3 logs on the left side. They all have a base 5. I'm adding and subtracting. That means that I could collect this entire left side into a single log. I have multiplication on the bottom, or addition between the first 2 logs, and therefore I have multiplication on the inside. I then have subtraction with the last log, which means division on the inside. Well, now I have a single log equal to a number, and therefore I can change that back into exponential. And so I've got x squared minus 3x plus 2 all over x plus 6 equals 0, and you're good to go. Did you catch my mistake? I don't know if there's something in the visual that we get so used to solving equations over the last few years equal to 0 that maybe we jump the gun a little bit and we write down equals 0 on the right side. I hope we can see that is our mistake. I need to get rid of that equals 0 because my mistake was in changing that into exponential form. Notice I have 5 to the exponent 0 is equal to my result. And therefore 5 to the exponent 0 is going to equal 1. I come in on that line, and now I have a pretty straightforward equation. We should be able to fly through this to be able to go through and solve. I'm betting an awful lot of people really wish that that minus 4 on the end was a plus 4. So we see it doesn't factor, and therefore I need to use quadratic formula. My b squared minus my 4ac all over 2a. And now when I collect that pretty quickly, I can reduce my radical, my 32 being 16 and 2, and therefore I have 4 root 2. And we can reduce that all down to that. Again, take a peek. Can we accept both of those solutions? I take a look at the 2 plus 2 root 2, and I'm going to take 2 and I'm going to add on a bit. Well, if I take 2 and add on a bit, then I will have a value that will give me a positive in the first, a positive in the second, and a positive in the third. My 2 plus 2 root 2 is a valid solution. However, when I take 2 minus 2 root 2, I'm going to take 2 and subtract 2 in a bit. I can see that that's going to give me a negative value. And so if I go and sub that back into my first log, I'm going to now take a negative value, subtract more. That tells me that I cannot accept that value. And therefore, the negative is inadmissible. And there we go. If you were to go through and provide me a red solution to that equation, you were doing great. And hopefully we matched up in the end. So, job now, jump in and get some practice, and hopefully things go well. Good luck.